Hey guys, Miss Stubb here. I'd like to welcome you to my farm. Now you're probably thinking, what has being on your farm got to do with comparing functions? Well, let me tell you, we use a lot of math around here on the farm, from taking care of animals and buying feed, taking care of equipment, growing our garden. We use math every single day. On our farm, we've got about 30-something different animals, and today we're going to use some math to compare how much each of our animals eats per day. The standard we're going to look at today is 8.F.2, and it says to compare properties of two functions, each represented in a different way. What that means is we'll have a table, a graph, and an equation, and we'll look at the rate of change for each one and make some comparisons about the problem. Rate of change is how one quantity changes in relation to another quantity, such as miles per gallon or dollars per pound. Rate of change is also known as slope, rise over run, change in y over change in x, and unit rate. Let's look at an example. So the first way to find the rate of change is by using a table. And we use the letter M to represent our rate of change. And the formula for this is the change in the y values divided by the change in the x values. So in our table we have here, our y values are increasing by 5 every time. 12 plus 5 is 17. 17 plus 5 is 22. 22 plus 5 is 27. And we could even continue our table on using that pattern. Our x values are going up by 2 every time. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Okay? So to find the rate of change, all you have to do is say the y number that you got, so positive 5, divided by our x number, positive 2. And 5 over 2 is simplified as much as it will, so that is our rate of change. The second way to find the rate of change is from an equation. And when we do this, you need to make sure your equation is in slope-intercept form. And that means it needs to say y equals some number times x plus another number. And when you have it in this form, the rate of change is super easy to find. It's the number in front of x. Remember, rate of change is also known as slope, so that's where that comes from. And then the number on the end by itself is the y-intercept. Okay? So in our first example here, our equation already is in slope-intercept form. It says y equals 5x plus 2. So our rate of change is just the number right here in front of the x. Our rate of change is 5. Now the second example is not in slope-intercept form because the y right here is not by itself. So to get it by itself, we need to cancel out this minus 6x. And to do that, we're going to use inverse operations. So the opposite of minus something is plus. We like to keep our equations balanced, so what you do on one side, you have to do on the other side. That cancels this right here out. And then over here you've got 7 plus 6x. Now 7 and 6x are not like terms, so you just leave them as they are. To put it in true slope-intercept form, you can change the order of the two terms there. Now that we have slope-intercept form, we do the same thing. Our rate of change is just 6. So the third way to find rate of change is from using a graph, an x and y coordinate graph. And we do that by using what's called rise over run. And the rise value is the y-axis, how much it's increasing or decreasing. And the run value is the x value, the x-axis, how much it increases or decreases. So to do that, you have to have 2 points, and I've got 2 points marked here on our graph. And I always tell my students to start with the point on the left, so I'm going to start right here. And to get down to the next point, I have to go down 2 units. And since we went down, that's going to be a -2. That's our rise because we went up and down. To get our run value, you count how far you go left or right. So from here over to here is 1, 2, 3 units. And then you simplify your rate of change if it will simplify. -2/3 will not simplify. So there's our answer. So let's look at an example problem. It says, which function has the lesser rate of change? So we're going to find the rate of change for both functions and pick which one is the smallest. Evan's function gives us the equation y equals -2x plus 5. If you'll remember from earlier that if your equation is in slope-intercept form, which ours is, the rate of change is the number in front of x. So in Evan's function, his rate of change is -2. Liz's function gives us a graph. If you'll remember from earlier, to find rate of change on a graph, you use rise over run. So I'm going to pick 2 points. I'm going to use this one and this one. And you count how far up and down they go. That's your rise number. Then you count how far they go left and right. That's your run. So I go down 1, 2, 3, 4 blocks. So that's -4. And I go over 1 block, so the run is 1. -4 over 1 just simplifies to -4. Now the question says, which one is the lesser rate of change? So I got -2 and -4. -4 is smaller, so Liz would be the correct answer. Let's look at another example. Beth opened a savings account with $50. She puts $10 into the account each week. Juan also opened a savings account. The amount he is saving is shown in the graph. Who is saving more each week? Well, just by reading, we know that Beth is saving $10 each week. So I'm going to make a note of that. For Juan, we're going to have to find the rate of change from his graph. So I'm going to pick this point and this point. And I pick those points because they go right through the grid on our graph. So this one is at 40. This one is at 70. So from 40 up to 70, that's up 30. And then I'm at 1. I go over to 3. That's 2. So rate of change is rise over run. So I'm going to say 30 divided by 2, and that simplifies to 15. The question asks who is saving more each week. 15 is greater than 10, so 1 is saving more. Now, back to my farm. You thought I forgot. Here's the animals we're going to talk about today. We have our horse Patches, our cows, they don't have names, and our sweet little pig named Bacon. Let's talk about what they eat. The amount our horse eats per day is represented by this table. If you'll remember from earlier in the video, we talked about how to find rate of change from the table, and we used the formula change in y divided by change in x. In this case, our x value are going to be our days, and our y values is the amount of food. The amount of food is increasing by 18 each time, and our day is increasing by 1. So to find the rate of change, I would say 18 divided by 1 which is just 18. Our cows, their information is given by the equation y equals 26x. And it says where y is the total amount of food and x is the number of days. Our equation is in slope-intercept form, so the rate of change is the number in front of x. So our cows eat 26 gallons per day. Our pig's information is given by the graph. And to find the rate of change from a graph, we're going to do rise over run. So I'm going to pick some points. They're kind of hard to see. I'm going to use this one. That's at 16. And this one is at 32. So from 16 up to 32 is 16. And from 2 over to 4 is 2. And 16 over 2 simplifies to 8. So our pig eats around 8 gallons per day. So which animal eats the most per day? Let's compare their rates of change. The horse ate 18 gallons per day. Our cows eat about 26 gallons per day. And our pig only eats 8 gallons per day. So the cow is the winner. They eat the most feed per day. Did you know that we also have a garden on our farm in addition to all of our animals? We grow lots of different fruits and vegetables every year. Now, before we talk about the garden, let's talk about one more important piece of functions. It's called the initial value. Now, the initial value is the y-intercept on a graph. It's the starting value for your function, or it's the value when x is equal to 0. It's also known as the b value in the slope-intercept form of y equals mx plus b. So, for example, if you're saving money and you say you start with $10 and you add $15 per week, $10 would be your initial value, and then the $15 per week would be your rate of change. So let's talk about the garden. It says Miss Stubblefield planted lots of vegetables in her garden. Her tomato plants were 6 inches tall when she planted them and grow at a rate of 0.05 inches per day. The growth rate of her peas can be represented by the equation y equals 0.15x, and the growth of her squash plants can be represented by the graph below. Which plant grows at the fastest rate, and which plant was the tallest at the time of planting? So there's a lot of information in this problem. So let's look at what it's actually asking us to do first. The first question says, which plant grows at the fastest rate? So we're looking for the rate of change. So let's talk about the tomatoes. It says they were 6 inches tall when she planted them, and they grow at a rate of 0.05 inches per day. Well, that kind of gives us the rate in that sentence. 0.05 would be the tomato rate. It says the growth rate of her peas can be represented by the equation y equals 0.15x. And if you'll remember from earlier, our equation is in slope-intercept form. So our rate of change is just the number in front of x, 0.015. And then the graph shows our squash plant's rate. And so if you'll remember from earlier, we're going to have to find the rise over the run. So I'm going to start right here. This is at 4, and we go up to 5. So that's plus 1. And then 1, 2, 3, 4, 5 is the run. Now we could leave it as 1/5, but since my other numbers are decimals, I'm going to go ahead and divide that out, and you get 0.2. So the question says, which plant grows at the fastest rate? Well, we're going to compare. You've got 0.2, 0.15, and 0.05. And then, obviously, the biggest one is 0.2. So the first question, the answer is going to be the squash. The second question says, which plant was the tallest at the time of planting? And that's looking for our initial value. So if you'll go back to the tomato, it says that they started at 6 inches. The peas, that's an equation. If there is no y-intercept, you can add +0 to the end. So the peas actually started as a seed. There wasn't a plant for them to start with. And then the squash, the initial value is the y-intercept. So here's our y-axis, and it crosses right here at 4. So the plant that was at the tallest, we're looking at 6, 4, and 0. So the tomatoes were the tallest when we planted them. I hope you enjoyed learning about my farm and all the ways that we use math each and every day. Have a great day.